Hi, in previous video, in part 1, we discussed about the what is organic chemistry. Now, in this video, we are going to discuss about why carbon forms more number of compounds. Let us discuss once. So here, compared to all other elements, carbon only forms maximum number of compounds, and it leads to formation of a new branch for the chemistry, that is organic chemistry. Then why? Why only carbon forms those many of the compounds? Any compounds and the form cheyagలుగుతుంది. Let us discuss the reasons. So the first reason for that is catenation property. Now catenation. What is catenation? Catenation property is nothing but self-linking property. Self-linking property means atom of an element is combined with the same atom to form a chain-like structure. Means it is continuously combined. For example, one atom is there, carbon. Now the carbon is combined with another carbon and another carbon. Like that, it forms a continuous chain-like structure, and not only chain-like structure, and it is also includes the branches also. Okay, so here catenation is nothing but the self-linking property in which atom of an element is combined with the atom of the same elements in a chain-like manner, form a long chain-like structures and as well as branches also. Now this is, so in this carbon is combined with the another carbon, means self-linking. దానికదే ఆ కార్బన్ ఇంకో కార్బన్ ఆటంకి కంబైండ్ అయిపోతే it forms such long chain-like structures. Now this is catenation property. So due to this catenation property, carbon forms a long chain-like structures. And here the catenation not only observed in case of the carbon, catenation also observed carbon, silicon and as well as sulfur also. Okay, but here among these the carbon has high capacity, means the catenation property is very higher in case of the carbon. So fourth group elements, carbon, silicon, germanium, tin, lead. So these elements also shows catenation property. These are the fourth group elements, but here the catenation property is maximum in case of only carbon. So carbon shows high catenation property compared to all. Why? Because the size of the carbon is lesser and it forms covalent bonds easily, and whatever the covalent bonds found by the carbon, that is strong also. So the second property is tetravalency. Tetravalency. Tetra means 4. So carbon has 4 valence electrons. Let us discuss how it is. So carbon, Z is equal to 6, atomic number is equal to 6. Now electrons are 6. When you write electronic configuration for the carbon, so here 1s2, 2s2, 2p2. Now you can observe this 1s2, 2s2, 2p2. So now 2 electrons are there in the valence orbit of the, total 4 electrons are there in the valence orbit of the carbon. Now this is ground state configuration. When this is ground state. Now on excited state, from the 2s electron is shifted to 2p. From 2s electron is shifts to 2p orbital. So then 1s2, 2s1, 2p3. So generally carbon forms bonds when the electronic state is in excited state only. Electronic state is excited state. Now what is the valence orbit here? Second orbit is the valence orbit. Now how many valence electrons are there? 1, 2, 3, 4. So 4 valence electrons. So the last orbit which have electrons in an atom is called valence orbit. The number of electrons are there in valence orbit is called valence electrons. So second orbit which have the electrons are valence orbit. It has 4 valence electrons. So 4 valence electrons, tetravalency. And these 4 valence electrons are generally participate in the formation of the bonds in case of the carbon. So here the carbon Lewis symbols you can write like this. So C is the symbol for the carbon. It has how many electrons? 4 electrons. 4 are unpaired only. Generally we know that unpaired electrons are easily involved in the bond formation compared to paired. So carbon has 4 unpaired electrons in its valence orbit. So these 4 unpaired electrons easily involved in the bond formation. So carbon shows tetravalency. It has 4 valence electrons. These 4 electrons are very ready to involve in the bond formations. So the second reason, tetravalency. Due to tetravalency also carbon forms more number of compounds. So the third property is formation of multiple bonds. Carbon could able to form multiple bonds, means CC single bond and CC double bond and CC triple bond also. It could form these type of bonds. How? Let us discuss. We know that carbon has 4 valence electrons. 1, 2, 3, 4. 4 unpaired electrons are there in the valence orbit of the carbon. Now when two carbons are combined with each other, 1, 2, 3, 4, 1, 2, 3, 4. Now these two electrons are get combined with each other, these two orbitals get overlap, leads to formation of the CC single bond. This is one possibility is there. Next, for example, this is the another possibility to form the multiple bonds. So here these two electrons are get combined with each other. It leads to formation of the CC double bond also. This is also one possibility. So this is CC single bond. This is CC double bond possibility. Means these are again involved in another bond formation. Okay. So this is also another. The next, in between two carbons. So here 1, 2, 3, 4. 1, 2, 3, 4. Now these electrons are get paired with each other. This leads to formation of CC triple bond also. This is another possibility. So here carbon could able to form single bond, carbon could able to form double bond, carbon could able to form the triple bond. So these formation of multiple bonds are taken place by the carbon. Carbon ఈ multiple bonds form చేయడానికి ఛాన్సెస్ ఉంటాయి. కాబట్టి కంటిన్యూగా సింగిల్ బాండ్స్ ఫామ్ చేయొచ్చు, డబుల్ బాండ్స్ ఫామ్ చేయొచ్చు, ట్రిపుల్ బాండ్స్ ఫామ్ చేయొచ్చు. లేదు అంటే మిక్స్డ్గా సింగిల్ డబుల్, డబుల్ ట్రిపుల్ కావచ్చు, ట్రిపుల్ సింగిల్ కావచ్చు, అట్లా ఏదైనా ఫామ్ చేయొచ్చు. నాట్ ఓన్లీ విత్ రెస్పెక్ట్ టు సిసి కార్బన్ కార్బన్ మధ్యలోనే కాకుండా ఇట్ ఆల్సో ఫార్మ్స్ లైక్ దిస్. సో కార్బన్ విత్ ఆక్సిజన్ 2 bonds and carbon with sulfur also 2 bonds and carbon with nitrogen 3 bonds. So like this. So carbon with also form a single bond with nitrogen. Like that, carbon could able to form the multiple bonds, single bonds, double bond, triple bond with the same atoms, or double bond with the oxygen, double bond with the sulfur, triple bond with nitrogen, single bond with nitrogen. Like that, it forms different types of bonds. So the fourth property is isomerism. Isomerism. Iso means same, mer means particles, nothing but units. Isomer, poly means many, mer means units. Iso means same, mer means units. Isomerism. Now what is isomerism? Isomerism is nothing but, here this is the phenomena in which two or more compounds exhibits with the same molecular formula, means same chemical formula, but different structural formulas and as well as properties. Okay, two or more compounds, the phenomenon in which isomerism is a phenomenon in which two or more compounds contains same chemical formula, nothing but molecular formula and have different chemical structures, nothing but structural formula and different properties. So your isomerism is a phenomenon in which two or more compounds contains same chemical formula. Chemical formula is same, means molecular formula is same, and have different chemical structures, means structural formula is different and property is also different. Means isomerism is the phenomenon in which two or more compounds exhibits with the, means they have the same chemical formulae, means same molecular formulae, but structural formula means arrangement of the structure is different, property is also different. That phenomenon is called as isomerism. And whatever the molecules which are exhibit that, those are known as isomers. Okay, the compounds which exhibit, the compounds which shows the property isomerism are called isomers. Whatever the compounds which shows that property, those are known as isomers. Okay, let us discuss in detail with an example. Let us take an example, pentane. So pentane, its formula is C5H12. The formula of pentane is C5H12. Means here 5 carbons are there. 5 carbons. CH3, CH2, 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 CH3. So here you can see that 1, 2, 3, 4, 5. 5 carbons, C5. Hydrogens 3, 5, 7, 9, 3, 12. So this is the formula of the pentane, and this is the one type of structure which is found by the pentane. Now this is called as N-pentane. N-pentane. Now another possibility is also there. That is CH3, CH3, CH2, CH3. This is called as isopentane. Isopentane. Now another possibility is also there. CH3, 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 CH3. Now this is called as neopentane. Neopentane. Now you can see this here. Here the formula is C5H12 only. Here also 1, 2, 3, 4, 5 carbons are there. Hydrogens 3 plus 3, 6, 7, 8, 9, 10, 11, 12. So C5H12 only. Here also, what's that? 5 carbons. 1, 2, 3, 4, 5 carbons. C5H12 only. So here the chemical formula is same. Chemical formula is same, means molecular formula is same. But arrangement of the particles means structural formula is different. This structure is different from this one. This one is different from this one. Chemical formula is same, but structural formula are different. Now those are known as isomers. Now these are the isomers of pentane. Now all these are isomers of pentane. So here what I mean to say that here this whatever the carbon is there, it shows the property of isomerism. Due to the isomerism only, it forms maximum number of compounds. That is one of the reason.
Thank you for watching. If you like this video, please share and subscribe to our channel for more videos. Thank you.